and give you a chance to ask questions. So number one kind of intends to start the morning off, on Monday morning, albeit. Something like number one, right? There's a lot of fractions and stuff going on.
That was pretty great.
I'm kind of curious what you all did first. I really think there's two different paths you could take here to solve number one. Any suggestions? What do you think, Noel? So he says distribute, and Noel says distribute. Anybody have an alternative idea? Kind of curious if you thought this one over. Morning. Okay, so we'll go ahead and do the distributive property, but let me show you this alternative real quick. At least I'll just show you the start. Isn't that 3 a little problematic? So what if I just dealt with the 3 right away? Couldn't I divide this whole side by 3 and this whole side by 3? And if I did that, I'd end up with -2 plus, I guess I don't need the parentheses anymore. I would get -2 plus 3/2 x equals 8/3. I don't know that that's any easier than the way that you guys, most of you at least, said you did it, but that would be an alternative way. So let's do it the way you guys said, just so we could all see how it went. You guys distributed the 3, so if you do that, we end up with -6 plus 9/2 x equals 8. What do you think? Any questions on that step? Okay, what'd you guys do next? Add 6, okay. So if I add 6 to both sides, I get 9/2 x equals 14. Of course, 8 plus 6 being 14. So then we can handle this last step in one shot if we know what to do, how to deal with that 9/2. What do you guys think? How should I get rid of that 9/2 so that it's just x all by itself? Go ahead.
Multiply by the reciprocal.
Multiply by the reciprocal. Great idea. And the reciprocal in this case would be what?
2 ninths.
Not 2, it'd be 2/9. The reciprocal. You could do it in 2 steps. I like the doing it in 1 step idea. So if we multiplied by 2/9 on both sides, I think we got it. So these cancel, those cancel. 14 is really 14 over 1. When you multiply fractions together, you multiply the numerators times each other and the denominators times each other. I got 28/9. Or, if you are in love with mixed numbers, 3 and 1/9. I'm not a fan of that myself, but you could have gone there. You guys have any questions? Anything I can do to help? All right. As you guys know, at the end of our week, you'll have a quiz on this stuff. All right, number 2, I get to ask you this question again. If you're looking for the equation of a line, or really the graph of a line, what are the 2 things you got to have?
Point on the line and slope.
Yeah, point that's on the line and the slope. And right now, what do I have?
2 points on the line.
I've got a point on the line. You're right. In fact, I've got 2 of them. I need the slope as well. So let's figure out the slope first. Slope is usually represented by the letter m. And what's that relationship for slope? It's a fraction, right? And what goes in the numerator?
y2 minus y1.
Right, that's the change in y over,
Over x2 minus x1.
which of course is the change in x. That's one of those relationships we've got to have memorized, or we understand the concept well enough that we're super solid with that. So slope is equal to, I'd say my y2 would be 15, and then minus 5. It'd be 2 minus -3. Of course, that's 10 in the numerator and 5 in the denominator. Did you guys get a slope of 2?
Yeah.
Sweet. Okay, so now I've got a slope of 2, and I've got a point on the line. In fact, I've got 2 points on the line. Which of those points do I have to pick? Which one?
Either.
Yeah, either one will work. It really doesn't matter. So let's see here. Anna, which one did you pick?
The second one.
The second one works. So I'm going to use point slope to help me get started. I will write y minus 15 is equal to 2 times x plus, or minus 2, excuse me. And that, of course, is point slope. For me to get to slope intercept, what would be my first step? Distribute. Yes, distribute the 2. So if I distribute the 2, I get y minus 15 equals 2x minus 4. And if you remember, slope intercept is just the y by itself, y equals mx plus b. And so I'd need to get rid of that minus 15 by adding, yes. So I add that 15 over, and I got y equals 2x plus 11. Did you guys get the same thing? Any questions, concerns, little confusing things I did maybe? I don't know. It all makes sense in my mind, but sometimes something gets lost in the communication. Anything I can do. And then there's the arithmetic stuff, right? Everything should go well, and then arithmetic. It's a thing. All right. Number 3, let me just list these off for you. Domain for this one would be -2, 4, 7, and 1. And the range would be 5 and 1. All right, there's a bunch of 5s, but we only have to list it once. Any questions on number 3? Of course, domain goes with your inputs, which are x's. Range goes with your y's, your outputs there. Okay, and then the last one, is that a function? What we just saw there in number 3.
Yeah.
The answer is yes, you're right. And it's because why?
Each input has one output.
Yeah. Every input or each input has exactly one output. Sometimes people get a little bit bugged because -2, 4, and 7 all have the same output. It doesn't really matter. What matters is that each input has exactly one output. That makes this what we call a function. All right. Man, I'm really hoping that all this looks familiar, because haven't we done this a lot? And usually what you do a lot, you get pretty good at eventually, right? I'm hoping that you're pretty good at this. So it'll be a good week for you and a good DMR quiz and all that stuff at the end. I hope you're building your toolbox of skills. Any questions? No. All right. Well, if you watched and completed, learned from, and all that good stuff, the intro video, which about a little more than 2/3 of both of my classes total did. There's the intro right there. It's beautiful. If you haven't watched it, which there are definitely some of you that have not, you should. It's a pretty good video. So if you did, I think what we're about to do here is going to go by pretty smoothly. It's going to be pretty nice. Got 4 examples. And then once we've done these 4 examples, I think it'll be a good WebAssign time. Maybe preparation for your concept quiz tomorrow, whatever, we'll see. Okay, so I want to just ask you guys, number 1, what is the solution to that system of equations there in number 1? Say again?
There is none, they're parallel.
Yeah, it certainly appears that way, right? So what is the solution? I think a good response would be there is no solution. And Ava went on to say they are parallel. I'm assuming she's referring to those 2 lines. Certainly makes sense. So what's the big deal with those 2 lines being parallel? Like, why would that matter? They'll never intersect. That's true. And if they're parallel, meaning that they'll never intersect, why would that matter?
Yeah, the same slope.
Yeah, they do have the same slope, which makes them parallel. Or same slope, different y-intercept makes them parallel. But why would the fact that they will never intersect, why would that matter for our question? What's the solution to this system, Irene?
Because the solution is where the 2 lines intersect.
And if they never intersect, there's no solution. Does that make sense? Yeah? Okay, so no solution. They're parallel. You could say they'll never intersect. Something like that. And of course, when we have a system of equations, that's exactly what we're looking for. Where do the 2 lines intersect? Well, here in this case, they never intersect, so there's no solution. All right, so if you guys would, I'm thinking you're probably really good at number 2. We have graphed a lot of lines in the last month or so. If you guys would, please take a look at number 2. Please graph those 2 lines, and let's determine the solution to that system for number 2. So even if you're maybe you didn't watch the intro and you're not totally clear on what a system is yet, that is okay. I'm really, really hoping that you know how to graph a linear equation. Both of those are in a really nice form too, right? What form are those in? Yeah, it's right there, slope-intercept. So take a couple minutes, this is a good review, and let's graph those. What are the 2 things, Victoria, that you got to have to graph a line? Right. So for that first line, I'm gonna make this first line green. What is my slope?
2.
2 over 1 works. And Victoria, what's the point? Say again? Careful. Remember, a point always has an x-coordinate and a y-coordinate. So should always respond with something, comma, whatever. What do you think? 3 comma 0. She's really close, isn't she? It's 0 comma negative 3. Don't lose the sign in front. So it is the y-intercept, and the point there would be 0 comma negative 3. Okay, so Victoria set us up with a point. Somebody with a male voice set us up with a slope. I don't remember. Was that you, Chase? Or Ben? I don't know. Whoever that was.
Who? Me?
Maybe, did you tell us the slope?
Yeah.
2 over 1? Okay, awesome. So we're going to graph this. 0 comma negative 3 is right there. And then we go up to 1, 2, right 1, up to right 1. That sort of pattern there. And I get my line in there, and it does something like that. Okay, and then the other one, we're going to go with a nice blue line here. Jaden Jordan, what is the slope of that one?
Negative 1/4.
That's exactly right. And we got to have the point here. So Josh, what's the point on that line that we could use?
0,
0.6 is right. You see how everything's working out here? Let's see where what the second line looks like on a graph. So 0.6 is way up there, and my slope is down 1, right 4. So I'm going to go down 1, right 4, down 1, right 4, so on and so forth. I get this lovely blue line. That does roughly that. We get some arrows on the end. There's that. Well, let's remind ourselves when we're solving a system on a graph, what are we looking for?
The points that intersect.
Yeah, where the lines intersect. And right now, I didn't really draw my green line long enough, did I?
No, you didn't.
So maybe I should go back and fix that. So let me get rid of this. Oops, that's a really large eraser. Okay, so I'm going to recount my slope off. It was up to right 1, up to right 1. So go up to right 1, up to right 1, up to, oh my goodness, like I found it. Do you see it? Whoa, how cool. So I retry this whole line thing, and there we go. Not the most beautiful line, but that's okay. Isn't this right here? Isn't that my intersection point right there? Right inside my purple target? So when I'm looking for a solution, my solution will simply be that point, right? The coordinates for that point. So Faith, what do you got for a solution based on that particular graph? 4 comma 5. I agree. All right, 4 comma 5. That is my solution to this system. And I'm done. Let's think about what that means then. Wouldn't that point, 4 comma 5, wouldn't that need to make both of those equations true? Isn't that what a solution is? It makes the equation or equations true. So what should I be able to do with that point, 4 comma 5?
Test points before.
Plug it into the y and the x.
And testing it out, right? Is kind of what you're saying. I should be able to plug it in for the y and the x in the appropriate spots in both equations, and it should work. So let's do that really quick. We won't often do this, but I just want to show you how this works. So if I'm going to test out or check 4 comma 5, if I do it in the first one, this first equation is y equals 2x minus 3. What would go in for the y?
5.
5. And what would go in for the x? 4. So we just do a little arithmetic on the right side, following order of operations. 2 times 4 is 8. And 8 minus 3, check it out. It checks. 5 really equals 5. I know, Ben, it's shocking, especially for a Monday morning. Controversial and everything. And then, if it works in one of them, if it's where the two lines intersect, it better work in the other one too, right? So, I would check 4, 5 on y equals negative 1/4 x plus 6. The 5 would go in for the y, and the 4 would go in for the x. What is, on that right side, what is negative 1/4 times 4?
Negative 1.
It's negative 1. So 5 equals negative 1 plus 6. Well, negative 1 plus 6, it's 5. So 5 equals 5. It does check. So in other words, the point 4 comma 5 makes both linear equations true. Not just one of them, but both of them. Make sense? Simply because that point is on both lines. That's really the idea. Okay, any questions at all? And that's the only one. That's the only one that's on both lines. All right, so with that in mind, would you guys please peek ahead to number 3? I want you guys to try number 3. Is that point a solution to the system? Give a reason or show some steps
No.
for your answer. For a question like number 3, again, just want to reiterate this for you. If number 3 was a quiz question and all I put was this, and according to Coy, that is the correct response. If all I put there was no, even though that's the correct response, you're going to get no points. Okay? Not because you're wrong, but because you didn't explain yourself. It is a 50-50 shot. It's a coin flip, yes or no. Just because you guessed right doesn't really mean much of anything. It just means you got lucky. And I'm trying to understand, do you understand this? I'm trying to measure that. Okay, so if we're going to confirm or deny Coy's idea, we need to have a way of doing that. So what do I do with that -2, 1? Coy?
Plug it into the exponent.
Yeah, in both lines, right? Not just one. You're going to get both. So if I'm going to check y equals 1/2 x plus 2, I'm going to do just what Coy said there. The 1 would go in for y. The -2 would go in for x. On the right side, what's half of -2?
1/4.
No, because it's really this. What's half of 2? Half of 2 is 1, so half of -2 is -1. Yeah. So 1 equals -1 plus 2. And that right side, -1 plus 2 is 1. So that appears to check. Maybe Coy is wrong. Maybe not.
Second one doesn't.
Hey, there's a first time for everything, right?
The second one doesn't.
Okay, so y equals 4x plus 7. We're going to do the same thing. I'm going to plug in the 1 for the y and the -2 for the x. And 1 equals -8 plus 7. Whoa, this maybe looks like it is going to work, but wait. You get -1 on the right side. 1 does not equal -1. And so, because of that, because one of them was true, which is great, the other one was false, though, is that point a solution to the system? No. Coy was correct. And my reasoning is my work, right? I point to this right here. That's really the main reason why. So, is the point -2, 1 on either of those lines?
On
Which one is it on?
the first one.
First one.
Yeah, the point -2, 1 is on the first one, but not on the second one. In order for it to be an intersection point, it's got to be on both. Okay, cool. Any questions? The concept making sense? We're looking for intersection points between these two lines. That's a big concept. Okay, all right, so then your final challenge then would be number 4. Similar to number 2, maybe a little bit more challenging. If you guys would, please take a look at number 4 and try it.
A point and a slope.
Point and a slope. So what's the slope for this particular line, the orange one that I've got up there?
Y equals -2x plus 5.
But what's my slope?
Oh, -2x.
Remember, no x here. Whenever, for a line, your slope should always be constant. And so the x is your clue that the -2 is the slope, but the x is not included with the slope.
Okay, so that would be -2/1.
Sure, that works. And what is the point?
5.
Remember a
Or
point?
0, 5.
There you go, 0, 5. All right, so Aiden has got us set up for success here. She's given us the slope and the point for this particular line. I'm going to start by plotting the point, and the point is 0, 5, so that's right there. And I go down 2, right 1, down 2, right 1. And if you guys remember from before, when I graphed that one line, I didn't quite make it long enough to see the intersection point. And so I'm going to try my best to get that right. Something like that. So I got that line all the way in there, put some arrows on the end of it, and there we go. So far, so good? Okay, so the other one is not in slope-intercept form. That would be a handy form to put this in. So if I was going to try to put this in slope-intercept form, Chase, what would I do first?
You would change the -6x, you would flip it to the other side, that way you have y by itself.
Okay, so then if I did that, 3y would equal,
15 minus 6x.
okay, I think that's a good move. And then other Chase, what would I do to finish this off to get it all the way in the slope intercept form?
Divide by 3, like, both sides.
Sure. And if I did that, what would I get?
You get 5, or y equals 5 minus 2.
Okay, so what do you guys notice about the blue line? Kind of interesting.
They're the same line.
Oh, it is the same line, right? So the point and the slope are the same. So if I graph this, it's going to be the same graph, right? So you could say, well, it goes here and here and here, and I graph this lovely blue line this time. And so, of course, since it's the same line, the graphs are going to be right on top of each other, and there's my arrows. You can kind of still see that orange line peeking through there a little bit, right? Yeah, essentially these lines are right on top of each other. This is pretty unique, right? So remember that the solution to a system is the point where the lines intersect. So where do these lines intersect?
They don't.
Everywhere.
They do intersect, and everywhere is actually a pretty good description, isn't it?
Every point on
For
the line.
every single point on the orange line is the same as every single point on the blue line. And so, do you guys remember the very first example we did here this morning? The two lines were parallel, and so what did we say?
No solution.
No solution. How many solutions do you think we have with this one?
No,
Infinitely many. Yeah, so it's infinitely many solutions. Infinitely many solutions, because the lines are the same line. They're right on top of each other. So all of their points intersect, and because the lines go on forever and ever and ever, we have an infinite number of solutions. Okay? Any concerns or questions? All right, so you guys have about 16 and a half minutes, which is a pretty good chunk of time. Work on your web assignments. Of course. I'll be around to help.